Welcome to qnawire.
So now we're going to work on problem 68 from chapter 13. In this problem, we're asked to prepare two aqueous solutions. In the first one, we're given a solid that we need to dissolve in a certain amount of water, ethylene glycol. And in the second one, we're asked to basically make a dilution of nitric acid. So we're dealing with molality in the first one, and in the second one, mass percent. So for part A, let's start with the information that we're given. For ethylene glycol, we're given 3.10 times 10 to the 2 grams as the mass of ethylene glycol we're putting into this solution. And our target concentration is 0.125 molality of ethylene glycol. So the question is, how do we prepare the solution? So we can assume our own volume for the moment. What we're worried about right now is just figuring out how much water we need. So let's assume 1 kilogram of water. So if there's 1 kilogram of water, that means that this 0.125 molality is also equal to 0.125 moles, because molality is moles per kilogram, and if it's 1 kilogram, that means there's the same number of moles. So 0.125 moles times 62.07 grams per mole, this is the molar mass of ethylene glycol, is equal to 7.759 grams. So now we know how much mass of ethylene glycol there is in a solution of this concentration in 1 kilogram of water. So we're going to go ahead and make a ratio now. So we know 7.759 grams of ethylene glycol for every 1,000 of solution. So this value here is coming from the mass of water, 1 kilogram or 1,000 grams, plus the mass of ethylene glycol. So this is our ratio. Now, if we multiply this ratio times the amount of ethylene glycol that we get into, or we have to dissolve in the solution, 3.10 times 10 to the 2 grams, then grams of will cancel, and we're, sorry. So the initial, this is the grams of solution, not of ethylene glycol. So down here it will be of solution as well. So grams of solution cancels, and we're left at the end with grams of ethylene glycol, which is 2.39 grams. So this is how much ethylene glycol is needed to make this entire solution here. Now, how much water is needed? We know the entire mass of the solution, which is 310 grams, which is this value. So let's subtract the mass of ethylene glycol, and we get 308 grams of water. So to make the solution that we're required to make, we just need to combine these two. So let's look at part B, where we're asked to basically we're diluting nitric acid solution to a more dilute solution. So we're given 1.2 kilograms of 2.2% by mass nitric acid, and we need to prepare that from 52% mass nitric acid. So first, let's see how much nitric acid we need. What's the mass of nitric acid? Not the mass of solution, but mass of HNO3. So we know that our solution our target solution is 2.2% nitric acid. And so if we put that over 100, because that's the total mass, representative of the total mass. Now we want to make 1.2 kilograms, so that's the total solution. And so if we multiply it by the percentage of nitric acid, then we'll get 0.0264 kilograms of nitric acid. So that's actually the mass of nitric acid we need. So the question is, what volume of concentrated nitric acid do we need to use to get that mass? So our concentrated solution is 52%, again, over 100%. So if we multiply this times the mass that's needed, we get to our amount of nitric acid, which is 0.2, excuse me, 0.0264 kilograms. So if we divide both sides by 52 over 100, then this value comes out to be 0.0508 kilograms of the 52% solution. So we know the mass that we need of the solution. The question is, what mass of solvent do we need? So solvent needed our final mass should be 1.20 kilograms. So we just need to subtract the amount of nitric acid that we're adding, the amount of solution of nitric acid that we're adding, and we get 1.15 kilograms of water. So to prepare the second solution, we need to combine these two values.